Leap Second Mystery: How Chinese Dam Affects Earth's Rotation. The unseen impact of a single second, how Earth's rotation is being rebalanced by natural forces. In a world where timekeeping is as precise as a heartbeat, scientists are quietly monitoring a phenomenon that could redefine our understanding of Earth's spinning rhythm. As the planet approaches its maximum rotational speed, researchers warn that even the smallest shifts in its spin could ripple through global systems, like satellite navigation, climate patterns, and human daily routines. But here's where it gets controversial. While we've long relied on leap seconds to keep clocks aligned with the Earth's rotation, recent studies suggest that natural forces may be altering this balance in ways we've yet to fully grasp. Scientists predict that Earth's rotation could accelerate as early as 2025, with the maximum speed potentially occurring on July 9th, 22 or 5 of that year. This acceleration, though subtle, could result in a 1.51 millisecond reduction in a day's length. While humans can't detect these changes, they're critical for GPS, global time synchronization, and cutting-edge scientific measurements. For instance, a 0.06 microsecond increase in day length could disrupt satellite signals or affect the calibration of atomic clocks. Yet the question remains, should we adjust the leap second? This debate has sparked a global conversation about the limits of our understanding of Earth's dynamic behavior. The Three Gorges Dam, a monumental engineering feat in China, has been highlighted as a potential factor in this shift. According to Dr. Benjamin Fong Chao from Shandong University, the dam's release of 40 cubic kilometers of water altered Earth's moment of inertia, causing a 0.06 microsecond delay in the day's length and shifting the axis of rotation by 2 centimeters. However, such changes are minuscule compared to the broader impacts of climate change, like the melting of Greenland and Antarctic ice sheets, which contribute to rising sea levels. Even if the Caspian Sea's water levels decline by 10 centimeters annually, the effect on Earth's rotation would be negligible, though it could be stronger than the dam's influence. But the story isn't just about Earth's spin. Researchers are also exploring how natural processes like tectonic shifts or atmospheric changes might accelerate the planet's rotation. In the case of the Caspian Sea, scientists are investigating why its water levels have been steadily dropping by 10 centimeters per year, a trend similar to the water loss from the Three Gorges Dam. If this water evaporates and doesn't return to its original location, it could theoretically slow down Earth's rotation. However, current instruments aren't sensitive enough to detect such shifts, leaving room for speculation. Most likely the complex movements within the planet, like the Earth's core dynamics, are driving this change, says Leonid Zotov, a leading researcher in the field. Yet despite decades of study, the exact mechanisms remain elusive. While oceanic and atmospheric models offer some insights, they struggle to explain the sudden acceleration observed since 2020. The shortest day in history, recorded on July 5th, 2024, was 1.66 milliseconds shorter than average, suggesting that Earth's rotation is speeding up at an unprecedented rate. This phenomenon raises questions about humanity's role in shaping planetary processes. Some argue that human activities, like dam construction, could influence Earth's rotation, while others caution against overstepping our understanding of natural forces. As the world watches this quiet shift unfold, the answer may lie not in adjusting leap seconds, but in embracing the complexity of our planet's ever-changing rhythms. Earth's rotation is speeding up. What's behind the shorter days? Have you ever stopped to think that time itself might be playing tricks on us? Well, it's happening right now. The Earth is spinning faster than it has in decades, and scientists are scratching their heads trying to figure out why. What does this mean for us? It could lead to a radical step, subtracting a second from our clocks for the first time in history. Let's dive into what's going on and why this matters more than you might think. Earth's rotation is picking up speed. Here's why that's significant. This summer, our planet has been completing its daily rotation quicker than usual. In fact, some days have ended more than a millisecond earlier than the standard 24 hours. For example, on July the 10th, 2025, Earth completed its spin 1.36 milliseconds faster than the usual 86,400 seconds. And it doesn't stop there. July the 22nd and August the 5th are expected to come in at 1.34 milliseconds and 1.25 milliseconds shorter, respectively. These small differences may seem trivial, but when they add up over time, they create significant challenges for keeping our timekeeping systems accurate. The importance of precise timekeeping. To understand why these milliseconds matter, we need to talk about atomic clocks, the most precise instruments we have for measuring time. Atomic clocks work by counting the oscillations of atoms in a vacuum chamber. They serve as the backbone of Coordinated Universal Time, UTC, which underpins everything from GPS navigation systems to global financial markets. However, Earth's rotation isn't perfectly consistent. It wobbles due to gravitational forces from the moon, changes in atmospheric conditions, and movements within our planet's liquid core. Satellites track these tiny variations by comparing Earth's spin relative to distant stars. This constant monitoring ensures UTC stays aligned with reality, but only if adjustments are made when necessary. Leap seconds, a solution with an expiration date. Since 1972, scientists have occasionally added leap seconds to account for Earth's slowing rotation. But here's where it gets controversial. Recently, Earth has been speeding up instead of slowing down. The last leap second was added in 2016, and since then, no further adjustments have been needed. In fact, experts predict that we might soon face the opposite problem, a need to remove a negative leap second. By 2035, organizations responsible for maintaining UTC plan to phase out traditional leap seconds entirely. If current trends hold, there's roughly a 40% chance we'll see a negative leap second before then. Imagine having one less second in a day. How would that affect your schedule? Or even larger systems like internet servers? What's causing this sudden acceleration? Several factors contribute to Earth's faster spin. First, tidal forces play a role. While the moon slows Earth's rotation near the equator, it actually speeds things up at higher latitudes. Second, seasonal wind patterns shift angular momentum back to the solid part of the planet during certain times of the year, such as when jet streams move differently in the summer. Third, dynamics within Earth's molten core can influence how quickly the crust spins. These effects fluctuate daily, but tend to average out over longer periods, making predictions reliable only up to about a year in advance. Climate change adds another layer of complexity, and this is the part most people miss. Climate change is also affecting Earth's rotation. Melting ice sheets in Greenland and Antarctica redistribute mass toward the oceans, much like how a figure skater extends their arms to slow down their spin. Without this redistribution caused by melting glaciers, we might already be dealing with a negative leap second. Additionally, rising sea levels caused by melting ice are subtly tilting Earth's axis, a phenomenon that could eventually rival the moon's gravitational pull in terms of impact. Scientists warn that unchecked global warming could dominate changes in Earth's rotation by the end of the century. So, what does all this mean for us? While the idea of slightly shorter days might not seem urgent, consider this. Every fraction of a second counts when it comes to technologies like GPS, telecommunications, and stock trading. Should we embrace the concept of negative leap seconds, or should we find new ways to adapt without disrupting these critical systems? And could climate change ultimately dictate the rhythm of our planet's spin? Share your thoughts below. Are we ready for a world where time itself becomes unpredictable? What if Earth spun out of control? The science effects. What would it be like to find yourself on a planet that seems to be spinning wildly out of control? Recently, Earth has recorded some of its shortest days ever, with the planet rotating so swiftly that it has reduced our typical 24-hour day by 1.4 milliseconds. While these rapid changes in Earth's rotation are subtle and often go unnoticed, many of us can relate to the feeling that our lives are spiraling out of control, at least on a metaphorical level. In my first novel, Circular Motion, I explore the implications of Earth accelerating not just by a mere millisecond, but by a full minute, an hour, or even 12 hours. Imagine if the Earth began to spin so rapidly that we could actually feel it. The immediate consequences of the sun rising and setting more frequently are easy to visualize. How many of us already feel overwhelmed by the lack of time in our daily lives? In Circular Motion, the characters find themselves increasingly burdened, struggling to meet the relentless demands of their fast-paced lives as their days grow shorter. Their productivity hinges on a high-speed global transport system, which ironically contributes to the planet's acceleration, creating a vicious cycle that exacerbates their challenges. However, as the planet's speed increases, the characters soon realize that scheduling conflicts are the least of their concerns. The spin of the Earth influences countless facets of life. For instance, it regulates the movement of molten metal within the Earth's core, which in turn strengthens the planet's magnetic field. A shift in this rotation could disrupt everything from animal migration patterns to the stunning displays of the Northern Lights. In crafting the narrative, I had to selectively depict certain effects while omitting others. Some effects were included for their entertainment value, like animals running amok, while others were chosen for their deeper literary significance. Upon discovering that cyclones would become more frequent, I recognized a striking connection, not only with the recurring theme of circles in my book, but also with the pressing climate issues that Circular Motion partially symbolizes. Cyclones, hurricanes, and typhoons depend on the Coriolis effect, the deflection of air and water as they move from the rapidly spinning equator toward the slower-moving poles. This phenomenon results in counterclockwise storms in the northern hemisphere and clockwise storms in the southern hemisphere. The faster the Earth spins, the more intense these storms become. Yet, the effect that captivated me the most, one that vividly illustrates the modern sense of disorientation and confusion, was how the planet's rotation would impact gravity. As Earth rotates, we're carried along with it, and a centripetal force is required to keep us grounded. Without it, we would be flung into space, much like a hammer thrown in a track and field event, or your glasses flying off your face if you spin too quickly. Thankfully, gravity secures our place on the planet. However, as the Earth spins faster, the sensation of gravity diminishes, making us feel lighter. I was both thrilled and slightly alarmed to learn that, in reality, Earth's rotation makes us feel about 1% lighter than we would if the planet was stationary, especially at the equator, where our speed around the Earth's axis is greatest due to the widest circle we trace every 24 hours. Further from the equator, this phenomenon becomes less noticeable, but arguably more unsettling. The direction of gravity, which pulls us toward the Earth's center, does not align with the circular path we take around the Earth's axis. Consequently, Earth's rotation not only weakens the sensation of gravity, but also creates a feeling of tilt. As a novelist, I immersed myself in envisioning how this would feel at increasingly higher speeds. I calculated the strength and direction of what the characters in the book refer to as gravity loss. In locations like London, California, and the Caribbean as the length of days dwindles from 24 hours to 20, then to 10, and finally to just 2. I pondered questions such as, what would a drunken brawl feel like at 70% of normal gravity? Where would a ball come to rest if rolled down a slanted Times Square? How would the Beijing skyline appear if it tilted away from us by 7 degrees? If the entire landscape is askew, does it resemble looking downhill? Not quite. Is 7 degrees a significant tilt? Somewhat. As the narrative unfolds, the world of circular motion becomes increasingly unbalanced. Ultimately, the most crucial question posed by the book is how we find a sense of belonging in such a chaotic world. In circular motion, every aspect of the characters' lives is influenced by the planet's acceleration, be it their relationships, career choices, or their sense of identity and faith. The characters are in search of love and purpose while feeling unmoored, disoriented, and tossed about by the whirlwind of modern existence. Sound familiar? Alex Foster's Circular Motion is the latest selection for the New Scientist Book Club. Join us and read along.